Decibels are used to measure sound levels, and we also use them in wireless communications and radio frequency engineering. Have you ever wondered why we use decibels? We'll consider a few reasons and examples.
Please see the video description for a full list of disclaimers, including the ones here, plus a timeline and helpful resources and links. Please support the channel by using our affiliate links.
Decibels are a nonlinear way of expressing ratios. Decibels are based on the logarithm function, specifically the logarithm base 10. Similar to scientific notation, decibels are a convenient way of representing very large and very small numbers and ratios, which we must deal with in radio frequency or RF systems. The advantage of using decibels is especially evident when we plot the ratios that we will be representing on a logarithmic scale. In this case, we can see that very small ratios, like 10 to the negative ninth, are represented by numbers like negative 90 in dB. And 1 billion, or 10 to the ninth, becomes positive 90 dB. The decibel numbers are much easier to manage. Consider a signal transmitted from a satellite. The transmitted signal could be several hundred watts, yet by the time it reaches Earth, it could be a billionth of that power level, or even less, depending on factors like the satellite's orbit and the type of antennas that are used. Instead of saying that the transmitted signal undergoes a loss of over 10 to the 20th power before it reaches Earth, we can say that the loss is over 200 decibels, or 200 dB. Although 200 is a large number if you are counting 200 of something, it is much easier to work with or imagine than 10 to the 20th power, which is 100 billion billion, or 100 quintillion. By using decibels, we also simplify some useful mathematical operations. Once we have expressed power ratios or levels in decibels, we can perform some math that would normally require a calculator using simple arithmetic. This is useful for quick, approximate back-of-the-envelope calculations, and with practice we can do many of these calculations without even needing a pencil and paper. For example, if we connect an ideal power amplifier that has a gain of 3000 to the output of a 400 milliwatt transmitter, transmit the signal over a channel that has a loss of 20 billion using an antenna that has a gain of 30, and the receiver uses an antenna that has a gain of 2, how strong is the signal received at the receiver? We're going to assume that the transmitting antenna and the receiving antenna are pointed directly at each other, so we can use the given gain values for the antennas. We can perform the calculation using the numbers that we were given. We won't necessarily need a calculator, but if we don't use one, the calculations could take a while. Instead, if you have memorized a few dB values and rules for math with decibels, you can do the operations quickly on paper, and with some more practice you would be able to do the entire calculation in your head. We have added the decibel values. These are based on some easily memorized decibel values that correspond to integer valued ratios, and some rules for calculating with decibels that are also easy to remember. Our goal is to calculate the received power. Because we're working in decibels, instead of multiplying and dividing the values that we're given, we will add and subtract them, so the operations will be much simpler. Also, when we look at these values, for now we're not going to pay too much attention to the letters that you see at the end of the dB abbreviation. Because LP is a loss, we subtract it rather than adding it. We'll pause briefly so that you can do the calculation yourself. I'll do the calculation too, and we'll see whether our answers match. Welcome back. This is the value that I got in dBm. Now, we still have to convert this back to milliwatts, and for that we might want to use a calculator. However, we might be able to perform an approximate conversion back to milliwatts without a calculator. We get 3.6 microwatts. Decibels are also useful when we need to view or measure strong and weak signals at the same time. In our final example, we will use a spectrum analyzer, which is an instrument that can display received signal power as a function of frequency. We've connected an antenna to the input of the spectrum analyzer so that we can look at signals from nearby FM broadcast radio stations. First, let's see how many stations you can count when the received powers are displayed in watts or multiples of watts, as they are now. Now we will change the display to show the received powers using a decibel scale. How many stations can you count now? Here are a couple of questions. Which scale would you want to use if you worked for a regulatory agency and were trying to locate a pirate radio station that was transmitting without a license? And which scale would you want to use if you were operating a legal, low-power, unlicensed transmitter and were only allowed to transmit on frequencies that would not cause interference to other signals in your area? We have seen how decibels can help us represent very large or very small numbers with more manageable numbers, and how using decibels can simplify calculations and save time. We have also seen how using decibels makes it easier to see weak signals when strong signals are also present. In addition, we saw a spectrum analyzer, an instrument that makes radio signals visible and lets us measure their frequency, strength, and other properties. Although high-end spectrum analyzers are very expensive, the one we used costs well under $100. If you would like to learn more about these low-cost spectrum analyzers and possibly get one for yourself, you can follow the link below. We have also included a link to a more capable spectrum analyzer made by the same company. If you make a purchase using either link, we earn a small commission, although your cost is the same as it would be if you didn't use our links. Thank you for your time. If you liked the video, please push the like button. We will also have some special items for subscribers, so please subscribe if you would like to learn more about that. Thank you very much.